ladies and gentlemen, boys and girls, good day. Welcome to the world of physics. Okay, let's try to have a look at the question today. The question is, how does damping affect the frequency? So first of all, we have to understand what is damping first before we can answer this question. Okay, in order to understand damping, let me show you a pendulum which is experiencing. So what is the definition for damping? Yes, here you are. It is a reduction in the amplitude of an oscillation as a result of energy being drained from the system to overcome frictional or other resistive forces. So the key words here is reduction or decreasing and also amplitude. So there is a reduction in amplitude. So when you define damping, remember the keyword. The keyword is reduction or decreasing and amplitude. So amplitude is decreasing. Okay, well, the damping affects the frequency. Let's try to study the graph of displacement versus time for a damping system. In this case here, we have a vertical axis which is a displacement and the horizontal axis which is a time. So as you can see from here, we can take the period from this graph. The period should start from here towards here. Alright, so from here towards here means I can indicate from here to here as T1. And also, as you can see from here, I can also take the period from here to here. Let me name it as T2. As you can see, T1 start from here. It takes 1, 2, 3, 4. 4 equal portion of the time axis. And for T2, 1, 2, 3, 4. So it is also taking up 4 equal portions. Let's try to study one more period for which can be taken from here to here, which is the time to make one complete oscillation. So this is the time. This is one complete oscillation. So this is the time taken. So let me name this as T3. And T3 takes 1 portion, 2 portion, 3 and 4. So altogether again 4 equal portions. So meaning to say T1 equals to T2 equals to T3. If that is the case, F1 equals to F2 equals to F3. And let's try to have a look at the amplitude. So the amplitude, as you can see from here, yes, this is amplitude. Let me name it A1. And this is another amplitude here. Let me name it as A2. And another one here, A3. Obviously, A1 greater than A2 greater than A3. So meaning to say, we can see a reduction or a decrease in amplitude, but the periods remain unchanged. As a result, the frequency remain unchanged. In conclusion, damping actually will not affect the frequency. The frequency will remain unchanged, or the frequency is a constant. Okay, so let me highlight the common mistake done by the student when they are asked to sketch the graph of displacement versus time for a damping system. This question has already been asked for a few times in the history of SPM. So let me highlight where the mistake is. Student tends to overemphasize on decreasing of amplitude until they have forgotten, in fact, the period should not be changed. But when you try to draw, then you will tend to make the periods getting smaller and smaller, as you can see from here. If this is T1, this is T2, and this is T3, we notice that T1 greater than T2 greater than T3, for which is not true. And of course, A1 and A2 and A3 is correct because A1 is greater than A2 and greater than A3, and this is correct. But T1 greater than T2 greater than T3 is wrong, so you cannot get a full mark for this question. So the proper way is actually try to preset the uniform divisions on the time axis first. Preset it first. This is the technique when we like to sketch this graph. Then only you start to sketch a graph. So this will ensure that the period is constant because the frequency is constant, as we have learned before this. So this is T1 and here is T2. As you can see from here, clearly T1 equals to T2. And look at amplitude, A1, A2 and A3. So A1 equals to greater than A2 and greater than A3. This is correct, and this is also correct. Then you can score a full mark for this graph. Okay, that's all for this question. See you. Bye-bye.
Huan Academy. You ask, we solve.